Integration time. So you'll find this point right here, intersection. So how we do this is we're going to put both of those into our calculator. 18 log of x, and g of x is 0.5 x cubed minus 8x squared plus 34.5 x minus 27. So that's 1018. We'll make our windows. We'll have, say, we'll have 0 to 20. That's reasonable. We'll have 0 to 12. Sure. We'll graph the function. So the intersect at x equals 4.506165. Just about that. So that's the x value of this. Just about 4.5. Now we do the integral from 1, because that's this value right here, to 4.5, the 4.5 number, plus the integral from 4.5 to, what is that, 10 of g of f of x. G of x. G of x minus f of x, and then this one it's f of x minus g of x. Okay. We have integral. I have the TA84 plus. So in this I can go from integral 9 of 1 to, I'll just manually put the number 4.05 6165 integral vars, y vars, and then you go function 1, you go 1 minus, and then y vars function 1, and we get function 2 d over dx. A negative number. I'm not supposed to get a negative number. Log of 10. I think I put them wrong. Oh yes, I definitely did. Yes. Put we'll do function 2 first, minus function 1 over dx. There you go. I get positive 2-ish, or 22-ish. And then I take the next integral. 4.506165 to 18, and it's 10. Again, I put the wrong bars. So we'll have 104. 104.644. Neat. What is this exact area? I have a number we don't see right there. It's tangent to the x-axis, and it goes, it's bounded by the y-axis and x-axis. This is the function. Let's see, we have more coffee. I'm trying to get there. So we're going to have integral 1 f of x is equal to 0. So if we put that at 0, we get 0 equals 3 cosine. I want to take out the 3, divide that. 0 equal cosine x plus 1 minus 1. 1 equal cosine x. Cosine equal pi. Cosine equal pi. So it'd be negative pi. The integral from negative pi to 0 of cosine 3 cosine x plus 3. So that's what we've been calculating. Oh. Let's see. No. Three cosine x plus 3 dx. And then, I'm going to manage that mechanically. Well, it's exact area, so I guess we'll just integrate it. Let's see. We have integral of 3 is 3x plus c. Integral of 3 cosine x is 3 integral cosine sine x from negative pi to 0. So if we get 0, the sine of 0, it's too early for this, I think that's 0. 0, 0. Negative 3 pi. Negative 3 pi. That's what I got. No, it's area. It can be negative. It has to be positive. Yeah, 3 pi. Okay. What is the area bounded by the curve? The y-axis is the line y0, and the line y equals 0. So the integral of dy of 6 to 0, 6 of 144y over y squared plus 4 squared. Trigonometric functions. It's not trigonometric. Oh. Trigonometric functions. Here we go. Trigonometric. Oh, you're supposed to integrate it. I don't think it's true. Use this little squared so we get u. So u equal y squared plus 4 the du is equal to 144. Yes, du is equal to 2y. And dx, so we get dx is equal to 1 over 2y, or dy, du, dy, du. So we get 144 y over 2y times 1 over u squared. Okay. We can cross out the first one. 144 divided by 2, let's look at 12 squared. 12 times 6 is 72. 72 is neutral. So we get 72, and then we'll integrate. We'll take the half integral. 6 to 0 of 1 over u squared, so we get u to the power negative 2. And if we integrate that, we get 72 times negative 1 over u squared. U is y squared plus 4 plus c, from 6 to 0. So negative 72 over y squared plus 4 from 6 to 0. 0 results in negative 80, so negative 20, negative 18. 6 results in 36 plus 440, negative 72 over 40. Let's see, we get 18 plus 72 over 40. Really want an improper fraction. Something like that. It's 18 minus 70 over 40, actually. Six, 4, 8, 18. think this is right. Needs to be simplified. 648 divided by 4. 40 divided by 4. 162 divided by 2. 10 divided by 2. 81. 6. 40. Divided by 5 is prime. Name. What's the area of the region bounded by the graphs? F of x is equal to negative x squared, g of x in quadrant 4. So 1, 2, 3, 4. I think that one's quadrant 4. 4. Okay. Negative x squared, so we go with negative parabola. Negative 3x minus negative 10. And then it shoots up like this. So what is this area? So that'd be the integral from 0 to, and the intercept right here. And then it'd be f of x minus g of x minus intercept. Okay. So we have f of x is negative x squared. X squared. G of x 3x plus minus 10. X equals negative 5. Okay, so negative 5 is intercepted from across twice, right? This is a problem. And so across twice calculate intercept. Square second curve gas 2 and negative 4. 2, yes. X equals 2. So we have integral from 2 to 0 f of x minus g of x. Let me plug this in the calculator, but I'm going to do it by hand. G of x is equal to f of x is equal to negative x cubed over 3 2 and 0, and then we have minus g of x is 3x squared over 2 minus 10. And then plug into negative 8 over 3 minus 12 over 2 minus 10. Zeros out, we get negative 10 at the end. Negative 10, 6, 8 over 3, that's 2/3. 8 over 3, 8 plus 6 is C. 2 we get negative 8 over 3 minus 4 12, 6, 2 plus 10 minus 10 and 10, 14, 14x. I think it's this. If 0, 0, negative x, from 0 to this, their intersect of f of 2 minus f of 1, area is positive. Trying to find the area of the graphs of f of x equals negative x squared, g of x is equal to 3x minus 10, and x equals 0 in quadrant 4. What is the integral? We're trying to find that integral. Negative, ooh, 12 over 2 is not 2, it's 6. Ooh. Yeah. x equals 10. I didn't get that part. That's why I was frustrated. Okay, I see. What's the area of the region between the graphs f of x is equal to negative 2 over 3 pi minus 5 over 3, and g of x is equal to cosine of x from x equals 2 to x equals 5 over 2 pi. So, we have the bounds. Our bounds are given. We have the integral from 2 pi to 5 over 2 pi of x squared over 3 pi minus 5 over 3 minus cosine x. Okay, so integral of first one, or integral, we'll do integral of the second one first. That is integral of cosine is sine, sine of x not c, and then we have integral of negative 5 over 3, which is equal to 5x over 3, and then integral of 2x over 3 pi, that is x squared over 3 pi. So we get equals x squared over 3 pi minus 5x over 3 minus sine of x. Yeah. And we just substitute values in. So we get 5 over 2 pi, 5 over 2 pi squared minus 2 pi let's see if we have x equal, let's put this in the calculator, we get x squared in parentheses x squared divided by 3 pi minus 5x 3 minus the sine of x. We get plus 2.5 pi. First value. We get put 50.50. That's an approximation. 2 pi. Next value. We get 30.87. So 50.50 minus 30.87. 19.92. And so that's 1 plus 3 pi. So we get pi times 3, or 6 pi, I mean. 6 pi plus 1. It equals just about that. Wow. I should probably double check my answer. So yeah, we'll have it again, I guess. So what is the area of the regions between the graphs of f of x equals 3x over 3 pi minus 5 over 3, and g of x is equal to cosine of x from x equals 2 pi to x equals 5 over 2 pi? Let's graph these equations. Y is equal to 2x over 3 pi minus 5 over 3. And cosine x from 2 pi to 3 over 2. 3 pi over 2. 5 pi over 2. Values, y values 3 minus values function 4 here dx. What was only like 16.9 if we get 6 pi minus 1. It's a little under 19.6. Doesn't make much sense for it to be large, actually. if he goes soon. So I spent 40 minutes on these 5 problems. Hate to miss the last one. So what is the area of the regions between the graphs? F of x is equal to 2x over 3 pi minus 5 over 3, and g of x is equal to cosine of x from x equals 2 pi to x equals 2.5 pi. That's the question. Yay. That was painful. We survived.